Hello friends, welcome to H2 Academy. In this particular lecture, we will discuss about the Gauss divergence theorem. So let's begin. So what is the Gauss divergence theorem? So the Gauss divergence theorem gives a relation between the surface integral and the volume integral. Okay. So let us understand this. So let us consider a surface S that is enclosing a volume V. Let us consider a surface S that is enclosing a volume V. Okay. And let us consider F as a vector point function. Vector point function. Okay, and unit vector along the outward normal is given by n cap. Okay, so the basic expression for the Gauss divergence theorem is f dot n cap into ds along the surface S is given by is equal to divergence of f dv. This is the volume integral. Okay, so this is the Gauss divergence theorem. So the basic condition for application of the Gauss divergence theorem is that this surface must be a closed surface. Closed surface. Okay, so let us link this with Stokes theorem. What we have seen in Stokes theorem, for the application of Stokes theorem, the surface must be an open surface. Let us consider a surface S like this, and it is being enclosed by a curve C. Okay, so this curve C is enclosing this surface S, and the unit vector along the outward normal is n cap. Okay, let us apply the Stokes theorem here, and f is a vector point function. F is the vector point function. Vector point function. Let us apply this. So we have f dot dr along the curve C is equal to surface integral along the surface S. This is curl of f dot n cap into ds. So this is Stokes theorem, and this is Gauss divergence theorem. So the basic difference is that the Gauss divergence is being applied on a closed surface, but the Stokes theorem is being applied on a open surface. Open surface. Okay, so this is the basic difference between the Gauss divergence theorem and the Stokes theorem. So now let us start solving the problems. Okay, so in question number 1 we have to what is given in question number 1? F is given by this particular expression where a, b, c are constant. Show that f dot n cap ds along the surface S is equal to 4 by 3 pi a plus b plus c, where S is the surface of the unit sphere. So let us solve this. So question number 1. Okay, so we have the value of f is given as f is equal to ax I cap plus by j cap plus cz k cap. Okay, where a, b, c are constant. Okay, so we have to show that f dot n cap ds along the surface S is equal to 4 by 3 pi a plus b plus c. This we have to show. Okay, where S is the surface of a unit sphere. Okay, so this S is the surface. Okay, and the radius is equal to unit, 1 unit radius of this sphere. So this sphere is a closed surface. Okay, so this sphere is a closed surface. So we can apply the Gauss divergence theorem. So using Gauss divergence theorem, we have f dot n cap into ds along the surface S. This is equal to triple integration along the volume V. This is divergence of f dv. Okay, so this is the Gauss divergence theorem. So we have to show f dot n cap ds is equal to 4 by 3 pi a plus b plus c. So let us calculate divergence of f. So the divergence of f is equal to del dot f. This is equal to I del upon del x plus j del upon del y plus k del upon del z dot product with value of f is this one. This is ax I cap plus by j cap plus cz k cap. So this is equal to del upon del x of, this is dot product, so I dot I is 1. So this is del upon del x of ax plus del upon del y of by plus del upon del z of cz. So this is equal to a plus b plus c. This is divergence of f. divergence of f is equal to this one. Let us place here. So this is equal to divergence of f is a plus b plus c, and this is equal to a plus b plus c. This is volume integral. This is dv. So this is equal to a plus b plus c is constant, a plus b plus c into this is volume v, volume of the unit sphere. So the volume of unit sphere will be 4 by 3 into pi into radius. This is 1 unit, pi a cube. This is equal to 4 pi by 3. This is volume v. So this is equal to 4 pi by 3 a plus b plus c. Okay, so this is equal to f dot n cap into ds. This is surface integral. Okay, so now let us discuss question number 2. Okay, so what is given in question number 2? N cap is a unit outward normal to any closed surface S. Show that divergence of n cap dv is equal to S. Okay, so let us solve this. How we can solve this? So what is given is n cap is a unit outward normal to any closed surface. Let us consider a closed surface S, and n cap is the unit outward normal to any closed surface S. Show that divergence of n cap dv is equal to S. Okay, so now let us apply the, since it is a closed surface, so let us apply Gauss divergence theorem. Okay, and let us consider f as a vector point function. So we have f dot n cap into ds along the surface S is equal to divergence of f dv. Okay, this is volume integral. Okay, now let us consider, let f is equal to n cap. So we have n cap dot n cap ds along the surface S. This is equal to triple integration along the volume v. This is divergence of n cap into dv. Okay, and the dot product of unit vector is 1. So this is equal to ds, surface integral along the surface S is equal to volume integral divergence of n cap dv. Okay, and this we can write as ds. This is the surface area, and surface area of this closed surface is given as S. So S is equal to divergence of n cap dv along the volume v. Okay, now let us discuss question number 3. If f is equal to del, let us discuss question number 3. If f is equal to del phi and del square phi is equal to 0, so that for a closed surface S, f square dv is equal to phi of f dot n cap into ds along the surface S. Okay, so let us solve this. Okay, question number 3 we have to show. So it is given in the question, f is equal to del phi and del square phi is equal to 0. Okay, we have to show that f square dv along the volume v, this is equal to surface integral phi f dot n cap into ds. Okay, let us solve this. So using Gauss divergence theorem, we have f dot n cap into ds along the surface S is equal to volume integral divergence of f dv. Okay, so let us replace f with phi of f. Okay, so phi of f dot n cap into ds along the surface S, this is equal to triple integration along the volume v. This is divergence of, this is del dot phi f into dv. Okay, so we have studied in the chapter of vector identity, del dot phi a is equal to del phi dot a plus phi times of del dot A. Let us apply it here. So this is equal to triple integration along the volume V del phi dot F plus phi times of del dot F. This is dV. Okay, so what is given in the question? F is equal to del phi and del square phi is equal to 0. So this is equal to triple integration along the volume V. This is del phi. Del phi is equal to, given in the question, del phi is equal to F. So let us place. So this is equal to F. So F dot F is F square plus this is, and we have del dot F. Del dot F will be equal to del dot, value of F is del phi. So this is equal to del square phi. So del square phi is given in question as 0. So this is equal to 0. So divergence of F, del dot F is equal to 0. So this is straight away 0. Okay, so this is equal to F square dV. So this is equal to, we have to show that this F square dV is equal to del phi F dot n cap ds. So this is phi F dot n cap into ds along the surface S. This is equal to F square dV triple integration F square along the volume V. Okay, this is we have to show phi F dot n cap ds is equal to F square dV. This is the result. Now let us discuss question number 4. So what is given in question number 4? F is equal to del phi and del square phi is equal to minus 4 pi rho. So that F dot n cap ds along the surface S is equal to minus 4 pi triple integration rho dV. Okay, how we can solve this? Let us discuss question number 4. Okay, so we have F is equal to del phi. So F is equal to del phi and del square phi is equal to minus 4 pi rho. We have to show that F dot n cap ds along the surface S is equal to minus 4 pi triple integration V rho dV. Okay, so this we have to show. So using Gauss divergence theorem, we have F dot n cap into ds along the surface S is equal to triple integration along the volume V. This is divergence of F dV. Okay, so this is equal to, this is del dot F. So del dot F, this we can write as del dot F. This is del dot, the value of F is del phi into dV. This is triple integration along the volume V. So this is equal to triple integration along the volume V. This is del square phi dV. Del square phi, this is equal to minus 4 pi rho. This is equal to triple integration along the volume V. This is equal to minus 4 pi rho into dV. Okay, so this is equal to minus 4 pi triple integration along the volume V. This is rho dV, and this is equal to F dot n cap into ds along the surface S. Okay, so we have to show that F dot n cap ds is equal to minus 4 pi rho dV along the volume V. So this is the basic expression that we have to show. Okay, so this is all about the Gauss divergence theorem. Thank you.